Thank you all for choosing this talk, or at least not getting up before the last one ended. We're going to talk today about improving productivity through composition. And if that sounds hopelessly abstract, I think it'll become clear as we go through the presentation. So my name is Matt Carroll. I'm an Android developer at Nest. You can find me on GitHub and Medium. And a quick disclaimer, there will be a lot of opinions. They're all mine. They're nobody else's. Possibly anybody else's in the world. We'll find out. But let's start by asking the question, what is productivity? We tend to think a lot about our IDE. We talk about our build system, frameworks, libraries, quick keys, macros. But that's very much about us individually. And really, productivity is rooted in our product. It's about the rate at which we produce. And most of us don't work at a company that is solely Android or app development. There are other roles involved. These are production roles. This is all of the pieces that come together to create our products and services and deliver value to our customers. So productivity is really about those roles getting their job done. So let's remind ourselves what those roles are, and then we can figure out how to increase productivity from an app's perspective. We'll start with marketing. Some of you may call this product management, maybe product design. But marketing is responsible for understanding our customers, our current and future customers, what they want, what they don't want, what they'll pay for, what they won't. So marketing decides what we end up building. And some requests that you might see coming from a marketing team include these. They might look at their customers and say, our customers are very security conscious, so we're going to implement two-factor authentication. Or they might look at a feature and say, only 2% of our users or our customers are using it. It costs us money to maintain it, let's scrap it. Or they might say, hey, our business needs to enter a new vertical. That requires these value propositions, go build it. Beyond marketing, we have design. Design decides how we build what we build, not from a technical perspective, but from that user experience. So commonly we'll hear things like, hey, we looked at the conversion rates on this form, they're terrible, let's take this long form and split it into two. Or they'll say we're rebranding, so we need to change all the colors and logos, fonts, etc. Or they'll say, hey, take the screen from this flow and replicate it in this flow right over here. These are very common requests from design. And there's apps, that's probably most of us. We deliver the user-facing value proposition. We deliver what the users see and touch. Then there's back-end services. Back-end services are responsible for the infrastructure upon which our apps are built. When it comes to back-end services, we are customers as app developers, so our job is mostly to adapt to the changes they have to make, often for scale. So they'll say, hey, we brought in new APIs, we changed existing ones, we deprecated old ones, and we need to be able to adapt to that. And finally, there's QA. QA is responsible for making sure that not only what we ship works, but it actually does what it was supposed to do. Now, the interests around QA are mostly around testing. So developers, please make this screen automatically testable, or please allow me to fake an input signal like a fake BLE signal so I don't have to do that by hand. These collectively are our production roles. You may have more in your organization, but we're not going to produce anything unless every one of these roles are involved. So your rate of production, your productivity, is limited by the slowest role in this group. So then the question becomes, what can we do? We're one of 5 roles. It turns out that apps are unusually central to all of these other roles. So what we can do is never be a bottleneck. That's how we can enable productivity. If we are never blocking the other roles, we will maximize that productivity. And the rest of this discussion is a bit about how to achieve that non-blocking proposition. So the central thesis here is that composition is the tool that we have as application developers to build nimble applications, applications that can change rapidly with low risk. This is not a nimble application. This is not what you should strive for in your application architecture. We don't know where a behavior begins or ends. We don't know what it touches along the way. Any change we make is high risk and will probably require retesting the entire system. This system, on the other hand, is so modular, we can eject features at runtime. I think that's pretty cool. But this system is built of smaller pieces that have well-defined interfaces between each other. You can add a new subcomponent, you can tear an old one out, you can adjust an existing one with segmented risk. And that's what we want to create nimble applications. So let's start by talking about a little bit of an abstract notion of composition, then we'll go into some tactics on Android. So let's introduce the concept of a hypothetical ride-sharing company. We'll use that through the rest of this presentation. I don't work for one, I don't know how they work on the inside, but I think we all know how ride-sharing typically operates. So let's look at how we might break down the problems that we solve for a ride-sharing company. First, let's note that there's two major categories of problems. There are business problems, and then there are application problems. Business problems don't have to do with a particular platform, and they aren't even relevant necessarily to the existence of apps. You could imagine scheduling rides and processing payments and rating people, even if there was no app. I mean, we used to call those taxi companies, and you call them on the phone and do those things. Then there are apps problems. These are the things that we often talk about at conferences and write about in blog posts, because anyone building an Android app or an iOS app, any client-facing app, needs to deal with these problems. Networking, caching and persistence, presentation, rendering. The important part about composition is to understand that at any given time, you're probably solving a number of independent problems. And not only are they independent, like presentation and networking, but they may belong to very different categories. They may belong to your business, or they may belong to the application. The reason this is important, the reason I'm harping on this, is because if you can't decompose your problems, then you can't compose your solution. So it requires that you think ahead about the barriers between the problems that you're solving. Once we understand the problems in this format, that these problems exist and they're independent, we can actually architect and package our code in a way that reflects these domain differences. So here we move from a problem space into a solution space. You can imagine looking at a structure in Android Studio like this. We have 4 modules. 3 of the modules come directly from the business problems on the previous slide: ride scheduling, payments, and ratings. And then, of course, there's an application module. We further subdivide those problems. Ride scheduling involves trips. There's also behaviors while you're driving, behaviors while you're riding. Payments involve both processing as well as probably an account to hold your credit cards and receipts. Ratings involve those for the driver, rider, and somehow processing disputes. So we continue to package our code and break it down by problem domain. Our solution mirrors our problem. And then our app becomes literally a composition of modules, which themselves are a composition of packages. Now you might say, well, why do I need to break things down in this way? Why does composing in this manner help? It's about 2 things again: the speed at which you can change and the level of risk you incur when you make the changes. Changes tend to occur within problem spaces. If your solution mirrors that, then your changes will tend to be confined. It's unlikely that changing the trips behavior is going to break the disputes behavior in ratings. Not just because we segmented the code, but because logically those problems are independent. All right? So now let's look at things that are a bit more tactical. So I would recommend, if you want a well-composed application, an application that's nimble, again with minimal risk, get as much code as possible out of the Android components. Android components essentially exist as a bridge to and from the operating system. One metaphor that I use is to think of your application as your house, and think of the operating system as everything outside. And activities and services and content providers, these are doorways between those 2 areas. You wouldn't take your sofa and your TV and your shelf and shove it in your doorway, and so you shouldn't build your application behavior in that doorway either. You're just cluttering things together and making it difficult to change. So let's take a look at how we might escape these components. Let's start with an intent service. So an intent service, again, exists as something for the operating system to orchestrate. It generally represents a unit of work that the operating system will run at some time. What can we do to move out of the intent service into our application? Well, we can ask a module for an instance of a unit of work. We'll call it a runnable. And then we can run it, and then we can go to lunch. And that's all most intent services really need to be. Now this is useful for at least a couple of reasons. One is that you may find that you have to turn this intent service into a job scheduler task. How much code do you want to copy and paste to do that? How much refactoring work do you want to do? What if you get a request from UI that says, no, we want the user to know this is going on, so please put that behavior in a loader? How much copying and pasting do you want to do? How much refactoring? If all you do is recognize that there's a unit of work and you abstract that notion, you save a lot of time and you minimize that risk. Now, how about an activity? Let's introduce the concept of a screen. And when the activity is created, we will ask for an instance of that screen object. We'll then ask the screen what layout hierarchy it needs inflated into the window, and we'll inflate it. And then we'll hand that layout hierarchy to the screen and say, go be a screen. Go do whatever it is that screens do, and when the activity is destroyed, we'll take that view hierarchy back. But here we've reduced an activity to a configuration. It sets things up, sets up your application, and your application executes. Now obviously this is a bit oversimplified. We aren't processing intents coming in or going out or starting activities for result, but there are similar ways to handle those issues as well. The point is, let's get out of the OS binding and into our application so that we can architect for our business, which allows us to change quicker with reduced risk. So dependency injection, my recommendation is use it. Use it everywhere. Whether you use a tool like Dagger or you do it manually, object-oriented programming, I think, really requires dependency injection. I'm not sure why we teach it as being something extra or unusual. It is literally the composition of objects together to create composite behaviors. So if we're going to compose our apps, we should start with dependency injection. And here's an example, again, continuing with this ride scheduling application. Let's say that we have a ride scheduler, and it depends on a trip router and a driver assigner. In this example, we're selecting the concrete implementations of those things inside the ride scheduler, which creates a number of problems for us. We cannot unit test the ride scheduler. We might be able to get away with an integration test. Then again, if it hits our production servers, probably not. We also can't A/B test a different trip routing algorithm. That's a request that we might see come from marketing. Hey, we want to try this way of getting from point A to point B. Please A/B test that. We're going to have trouble doing that. Or marketing might come and say, hey, we have these VIP customers, and we want to match them with certain VIP drivers. Please implement that behavior. Again, we're going to have a difficult time doing that because we've chosen the specific implementations. But if we just externalize those dependencies, we can choose the trip router and the driver assigner and compose the ride scheduler from them. Now the module that configures this instance can choose whichever trip router it wants based on the A/B test, and can choose the driver assigner based on whether the current user is a VIP or a regular user. All right, UI architecture. I don't care which of the alphabet soups that you use. I just recommend that you use one or more of them to solve your problems. Presentation and rendering really are their own problems. They are not the same thing as your business problems. So we want to decompose those problems and solutions as well. Going back to the screen example you saw on a previous slide, this might be how that screen works. So we have an activity that gets an instance of the screen. It gives the screen the view hierarchy, which you see on the left. And internally, there's a presenter object. It is the job of presentation to understand the business and map that business understanding to rendering configurations. So of everything on this screen, other than the business domain, the presenter is the only thing that knows we are a ride-sharing app, ride-sharing business. Okay? The view hierarchy just knows how to render. So it gets view models from the presenter and renders them. The screen is a mediator that goes between the view hierarchy and the presenter. With this breakdown, we can make changes to the view rendering without risking anything else. We can change the presentation without risking anything else. This allows us to move more quickly and adapt to changes. So for example, design comes in, says take the screen in flow 1 and replicate that screen in flow 2. We can do that in a matter of minutes with almost no risk. When we're asked to create a new screen, we can create a real activity, a real screen, a real view hierarchy, and by using a fake presenter, we can demo that screen to the designer exactly as it will be seen by users. We didn't have to wait for services to be built. We didn't have to implement any business logic whatsoever. We can show the real thing. And I think we all know designers always have opinions about things to change. So if it's going to change it up front. Don't wait until you build everything else and then review it. And also, presenters are essentially just mapping. They're a mapping from the business understanding to the rendering system, which makes them very easy to unit test. And not just unit tests on an Android device, for example, with instrumentation, but you can unit test them on the JVM, so you can test many of them very quickly. These are the kinds of benefits you can gain when you break down the responsibilities of your presentation and rendering system. Let's talk about custom views. I think you should use them. There was a time, and I don't know if it's kind of shifted in our industry, but there was a time when people thought the only place for custom views was when you're doing custom rendering. And I don't think that's the case. I mean, if I went out in the street and I said, please tell me what this is, most people would say that's a list item. They wouldn't say it's 2 text views and 2 image views. And yet we have a lot of code that looks like what's on the left. We just deal with these constituent pieces everywhere we go. We have adapters that list them out. We have activities that list every Android view. We should model our rendering the same way that our design team thinks about it. That will allow us to change more easily to the needs of the design team. By putting the list item in its own custom view, we can also set a view model on it. This allows us to use a presenter like you saw in the previous slide. It'd be much more difficult for a presenter to expose 2 strings and 2 bitmaps, but it can easily expose a view model. All right, let's talk about the chain of responsibility pattern, which is kind of like a simplified version of rule-based programming. It actually has a number of interesting uses in application development. I'll go through just one right here. Let's say when you launch the app, we might want to show a pop-up dialog to the user. Let's say if it's the user's first time in the app, we want to show them the welcome message. If they just scheduled a ride, we'd like to try to upsell them to like a VIP style ride. And every 10 times they come into the app, we want to ask them to join our VIP program. How might we solve this? I think you can imagine the if statements to do this. And initially it wouldn't be too bad, but as you add more and more rules to this system, it'll get out of control. You'll have embedded conditionals. It'll be very easy to break, very difficult to understand. Let's see if we can solve this from a compositional approach. Let's create a pop-up object, and it has the capability to display itself in a view container. If it wants to display itself, it does so and returns true. Otherwise, it does nothing, returns false. That allows us to create a chain of responsibility, which just includes a priority list of those exact pop-ups you saw before. We've now composed the behavior of which one to show and when to show it in a way that's very difficult to screw up, and it's very easy to understand. And it also represents the way that your marketing team and your design team probably thinks about those pop-ups. And let's see what this allows us to do in terms of adding a new one. Let's add a help pop-up. So if the user seems to be confused, we'll show them this help pop-up. It'll be the second priority in our list. To do that, we add a blank line, we call a new constructor, and again, we go to lunch because we eat a lot of lunch. So again, difficult to mess up, quick to do. So you respond to the needs of your marketing and design teams quickly, but you don't add a lot of new difficulty or responsibility to your QA team to validate these changes. Page objects, Jake's in the room. Jake calls these testing robots. Whatever you want to call them, we'll talk about how they can compose. So let's say we're on the QA team and someone's asked us to validate the behavior to schedule a ride. What might we do? We might go choose a destination. We might confirm our origin, schedule the ride, and then make sure it says the ride is scheduled. So if we're going to work in the domain of the problem, what might our test look like? It might look like a page object where you select your destination and you confirm your origin and you schedule your ride and you verify that the ride is scheduled. Page objects allow us to compose QA scripts in Android, in Java, whatever environment you're in. And the reason I say they compose is because even though this could be one page, it could also be 4. We might choose a destination on page 1, confirm our origin on page 2, confirm the ride on page 3, and verify success on page 4. It doesn't matter. What we represent is the user journey. We're able to represent our automated tests in the way that QA thinks about them. So when QA changes what they need, our tests change in an analogous way. We can change quickly with low risk. So to review, productivity is really about your product, your services. It's what you're delivering to customers. And that development process requires a number of different roles, and it's our responsibility as developers, where possible, to enable those roles to be as productive as possible. And my suggestion to you is that composition is really the greatest tool that you have as an app developer. to enable that productivity. So with that, thanks for listening, and go compose things. And any questions if there are any. Yes?
So from your example of the activity, you have a separate class or return
Sorry, which example?
with activity.
Sure.
And you have a screen class which return the layout. You consider the resource, Android resource as a part of Android. That's now like a screen class depends on the Android resource, so it still depends on Android.
Right, we haven't been able to totally get out of Android. There are some ways to segment things with interfaces. In terms of the view hierarchy, that view is going to be Android views. Even if you use custom views, yes, it's going to be Android views. But your presenter can truly be a Java object, and the entire business domain there on the right can be pure Java objects. So we've at least confined it to, let's say, the screen and the view hierarchy. And even the screen isn't doing Android work. It just has Android references. So it's not perfect, but it could be worse, right? So yeah, we haven't totally gotten away from Android, but the more you can get away, the more of those references you can cut, the better you can compose for your business rather than composing for the operating system. Does that make sense? Okay. Any other questions? All right, well, thank you.